Welcome back, dear students. So in the first session we have some basic introduction about engine, classification of engine, etc. So in this session we will discuss the major parts of an engine and terminology. That means the what are the major parts of an engine. Yes, this is a figure of a 4-stroke petrol engine. So with respect to this, we can identify the major part. The first important part is a cylinder. So you can see a cylinder block here. This is a cylinder. Then second one is a piston. This is a piston. And third one, we have a connecting rod. This rod is known as a connecting rod. And we have crank and crankshaft here at the bottom, and at the piston head, so head of the piston, we have two valves. This is known as the inlet valve and this is known as the exhaust valve, and we have two manifolds also, inlet manifold and exhaust manifold. And finally we have spark plug or a fuel injector placed in this position, that is at the topmost position between the inlet and exhaust valve. So these are the major parts of IC engine, but this does not mean that these are the only parts of an IC engine, because IC engine consists of several systems. For example, cooling system, ignition system, lubrication system. A number of systems are there in addition to this, and in that there will be a number of components also, but this is the basic elements that constitute of an IC engine. So we have a cylinder, piston, we have a connecting rod, crank and crankshaft, inlet valve and exhaust valve, then inlet manifold and exhaust manifold, and spark plug or a fuel injector. Now let's go deep into this one by one and see what are the functions of these individual components. So we will see the first part. The first part of IC engine is a cylinder. So the cylinder, this is the cylinder. You can see here, that is a basic structure of an IC engine, consisting of cylindrical structure. And this is the actual figure of what this cylinder looks like. So this is a multi-cylinder engine. In this is a single cylinder engine, this figure, but IC engines are normally multi-cylinder engines for getting high power. So this is an actual 4-cylinder engine, inline 4-cylinder engine. So what is a cylinder and what is its functions? The cylinder is firstly where the piston reciprocates. So inside the cylinder, the piston will be reciprocating up and down motion. It will execute inside this cylinder, and the cylinder is normally made in two parts. That is important one. Normally the cylinder is not constructed as a single part. It is constructed or cast into two parts, that is cylinder block and cylinder head. So this part, this bottom part, this part is known as cylinder block. So this is a figure of cylinder block, and the upper part, which contains the valves and spark plug etc., are mounted. It is known as a cylinder head. So normally the cylinder will be made into two halves and they are assembled together to form the complete structure. The inlet valve, exhaust valve and the spark plug is mounted at the cylinder head. So the cylinder head, we will have inlet valve, exhaust valve and spark plug, and the cylinder block will help to move the piston. Now the second part is of course the piston block. So that is the function of a cylinder. So the piston, this is the actual figure of a piston. It's mostly made of aluminum alloys, so it will have a shining appearance. And what is the role of piston? The piston is a cylindrical in construction and slides up and down inside the cylinder. This piston has several functions. This is one of the part which carry number of functions in an IC engine. What are they? The first function is to create vacuum during suction stroke. So this we will study in detail during working. So the first function of piston is to create a vacuum, that is pressure less than atmospheric pressure is known as a vacuum pressure, and that vacuum pressure is created by the movement of piston during suction stroke. And another function is to compress the charge. The charge means air fuel mixture, or air is known as a charge. So in charge in IC engine represents the air fuel mixture mostly. So the second function is to compress the air fuel mixture during compression stroke. And third function is to transmit the power, that is the in power stroke or in expansion the power will be produced, and transmit this force to the connecting rod. So here we have a connecting rod. So that is the third function of piston. And finally it helps to remove the gas, or pushing the already burned gas out of the cylinder, that is in the exhaust stroke. So all these are the 4 strokes. This we will study in detail in next session. So in all the 4 strokes the piston is having some function. In suction stroke it helps to create vacuum. Compression stroke it will help to compress the charge. In power stroke it helps to transmit the power to the connecting rod. And finally in exhaust stroke it helps to push the burned gas out of the cylinder. So all these are the functions of piston. And you can see here a groove is cut at the outer periphery of the piston. This is for the piston rings, because we know that there should be some small gap between the piston and cylinder, because it has to move smoothly with very high speed. So there should be a small gap between the piston and cylinder walls, and to provide a good tight seal between this we are providing a cylinder rings. These rings are known as the piston rings. So we can, normally 3 piston rings will be there. For every piston we will have 3 piston rings. They will be fixed in this groove. Here you can see 3 grooves are cut, and in that groove we will fix 3 piston rings. So that helps to provide a good seal between the cylinder wall and piston. And they are normally made of aluminum alloys. So piston is normally made of aluminum alloys. Now the next part. So we have completed cylinder, piston, then connecting rod. So this rod which connects the piston and crank is known as the connecting rod. So connecting rod, this is the actual figure of connecting rod. It has 2 ends. So one end, the small end will be connected to the piston here with the help of a pin and bearing, and the big end, this larger one is known as the big end of connecting rod, that will be connected here to the crank. So that is the connecting rod. So connecting rod connect piston to the crank and crankshaft. And what is the function of connecting rod? You have already seen the piston is moving a linear or executing a linear motion, reciprocating motion. But what we need is a rotation. The final output of engine is mechanical energy, which means a rotation, continuous rotation of crankshaft. So the connecting rod converts this reciprocating motion to rotary motion of the crank. So even though the piston is moving up and down, we require the crank movement in the rotary movement, and that is done by the connecting rod. So connecting rod converts the reciprocating motion of piston into rotary motion of the crank. And the upper end of connecting rod is known as the small end. This is the small end which is smaller in diameter, and the bottom end or the lower end will be larger in diameter, this one here, and it is known as a big end. So small end is connected to the piston and big end is connected to the crankshaft. and they are made of cast or forged steel. So the material used for manufacturing this connecting rod is cast steel or forged steel. So that is the role of connecting rod in IC engine. So next part will be the crank and crankshaft. So let's see what is the role of crank and crankshaft in an IC engine. So this is a crankshaft and crank. This is of a multi-cylinder engine. This is a crankshaft. You can see a shaft. So what is the role of crank? The crank in this figure you can see here, one end of the crank is connected to the big end of the connecting rod, and other end we have the crankshaft. So at the center of the crank we have a crankshaft, a shaft which we are taking power to the outside, and the other end of the crank will be connected to the big end of the connecting rod by a crank pin. So the one end of the crank is connected to connecting rod, and other end we have the crankshaft. And the power from the engine is imparted outside through the rotating crankshaft. So we already discussed in automobile, the crankshaft rotation is given ultimately to the wheel of the automobile through gear systems, or in a generator IC engine it will be given to a generator, etc. So whatever with the application, the power from the engine is taken outside through this rotating crankshaft. And the case in which the crank and crankshaft is enclosed, you can see a bottom case in which it is enclosed, and that is known as the crank case. So the crank and crankshaft will be enclosed in a cast iron case known as crank case. And this crank case also acts as a storage for collecting the lubricating oil. So that we will see later what are the functions of lubrication system. So for the time being, just understood that this crank case will also act as a storage tank for collecting the Then next we have inlet manifold and exhaust manifold. What is inlet manifold and exhaust manifold? It is nothing but a pipe. You can see here, this is the end of that inlet manifold here, cross section of inlet manifold, and this is the cross section of exhaust manifold. So what is that inlet manifold and exhaust manifold? It is just a pipe through which, inlet manifold is a pipe through which the air or air fuel mixture is drawn into the cylinder. So the fresh air fuel mixture or air will be entering through this inlet manifold. So it is simply a pipe through which the fresh charge will be entering into the cylinder. And similarly, exhaust manifold is another pipe through which the burned gas, the already burned gas, are removing in or escaping into the atmosphere. So you can see that end of exhaust manifold of an automobile we have the silencer. So silencer is used for reducing the noise of exhaust. So that is the connected in the exhaust manifold. So like that we have two manifold which represent simply a pipe. One is for carrying this fresh charge into the cylinder, other one is for carrying or escaping the burned gas out of the cylinder. Then we have inlet valve and exhaust valve. This is a very important part. We can see this is an inlet valve and this is an exhaust valve. So valve means we can open or close it according to its position. Suppose this inlet valve comes downward, means this passage will be open. The inlet manifold gets open. And similarly, if it go back, means in this position it is almost closed. The inlet manifold is closed. So like that we can control the exhaust valve also. We can open it or close it at different positions. And this is the actual representation or a real figure of inlet valve and exhaust. Here you can see this is a 4-cylinder engine. So minimum of 8 valve will be there. So minimum 2 valves So one inlet valve and one exhaust valve is required for one cylinder. So this is a 4-cylinder engine, so it is having minimum of 8 valves. So inlet valve is located at the cylinder head at the end of inlet manifold, and the inlet valve allows the fresh charge into the cylinder. So if you are opening the inlet valve, it will allow the fresh charge into the cylinder, but if it is in closed position, it will not allow the fresh charge entering into the cylinder. Similarly, exhaust valve is located also at the cylinder head, but it is at the end of exhaust manifold. An exhaust valve allows the burned gas to escape out of the cylinder. So if the exhaust valve is in open position means the valve come down, this opening will be free and the burned gas can go outside. But if it is in closed position, it will not allow the exhaust or gas to escape. So that is the importance of inlet valve and the exhaust valve. But then how these are open and closed, that is a question. Because this high speed machine, this opening and closing will be completed within microseconds. So who is controlling the opening and closing of this? So for that we have a cam and camshaft. So you can see here some cam is marked and camshaft, and this is that cam and camshaft. This shaft which pushes the inlet valve and exhaust valve, this shaft is known as camshaft, and we have the cam which help to push this valve up and down. So this opening and closing of valves are controlled by cam and camshaft, and they are made of, normally inlet valve is made of nickel chromium steel and exhaust valve is made of silicon chromium steel. So it is an alloy of steel, chromium and silicon, etc. And the opening and closing of inlet and exhaust valve are controlled by cam and camshaft. And another thing is they are connected to the crankshaft. Some connection should be there between the valve and crank, because at a particular position of crank we want to open one valve, and in another position of crank we require to close that valve. So therefore some connection should be there between the crank and crankshaft, and that is with the help of this timing gear or chain, etc. We will be connecting this camshaft to the crankshaft, so that when the crank is in a particular position, this cam will push the valve or it will open. Similarly, it will release the valve in some other position. So they are connected to the crankshaft. The camshaft is connected to the crankshaft with the help of a number of timing gears, chain, etc. So that is how we are controlling the opening and closing of these valves. And finally we have a part which is spark plug. This is here at the middle of the IC engine at the top, or it may be fuel injector also. We will see what is the role of this spark plug or fuel injector. This is a spark plug, the actual diagram of a spark plug, and this is a fuel injector. So even though they are somewhat similar, but they are entirely different functions. Spark plug is having one function, fuel injector executes some other function. So let's see what is that. The spark plug or fuel injector is located at the top of the cylinder head between the inlet and the exhaust valve. And what is the function of spark plug? The important thing is spark plug is mainly used in petrol engine only. In diesel engine normally the spark plug will not be present. And the function of spark plug is to provide the spark. We require a momentary spark for initiating the combustion of petrol and air mixture. So that is the function of spark plug. What the spark plug is doing is it will provide a instantaneous spark at a end of combustion stroke, which will initiate the burning of the air fuel mixture inside this combustion chamber. And this is a spark plug. So we can see here it is having two electrodes. The spark plug will be connected to battery and ignition system, and in between these two electrodes, this is one electrode, there will be a central electrode, and this is another ground electrode, and in between this we will be getting the spark. But what about fuel injector? Fuel injector is mostly used in diesel engines. They are rarely seen in petrol engines, but some petrol engine also use fuel injector, but still it is mainly used in diesel engines, and its function is to spray or inject the diesel with high pressure. So it does not have any function with the spark or ignition. But what the diesel injector or fuel injector will do is, it is having a nozzle here, and with very high pressure it will help to create high pressure, and it will inject the diesel in an atomized form into the cylinder. So both of this help to initiate combustion in a different way. Spark plug is used in petrol engine. It is used for providing a momentary spark. Fuel injector is used in diesel engine. It is used for injecting diesel into the cylinder. So that is the overall parts of an IC engine. Now finally we are going to the technology or specifications of an IC engine. So what are the important specifications of an IC engine? So first we have to understand the two terms, that is what is TDC and what is BDC. So TDC top dead center, BDC is bottom dead center. So what is that? It's nothing but TDC is the maximum point up to which the piston can reach when it is moving upward, or when it is at the top, that is known as the top dead center. So here you can see the piston can reach up to maximum this level. So we can mark this level as top dead center or TDC. And similarly, the maximum point the piston can reach when it is moving downward or when it is at the bottom part, it is known as BDC. So here you can see the piston can reach up to maximum here in the downward motion. So that point we can mark it as BDC or bottom dead center. So that is TDC and BDC. One is the maximum point. Top dead center is the maximum point reached when it is moving upward, and BDC is the maximum point it can reach when it is moving downward. And why it is known as a dead center? Because while reaching this point, the piston velocity will be zero, because it will reverse the direction. So once the piston reach TDC, it will reverse the direction. Similarly, reaching BDC also, it will reverse the direction. So at that point, its velocity becomes zero. So that is why it is known as a dead center. And another important term we want to know is stroke. So every engine will have a stroke or stroke length represented by capital L. What is that? It is nothing but the distance traveled by the piston when moving from one dead center to other. So you can see here the stroke is marked here. So what is the distance between TDC and BDC? That is named as stroke. So it is a distance traveled by the piston moving from one dead center to the other. So that is TDC, BDC and stroke. And normally the diameter of the cylinder or diameter of piston is known as a bore. You can see here it is marked here, bore. It represented by capital D. It is nothing but the diameter of the cylinder. This diameter of the cylinder is normally named as a bore. Now we have three volumes, important volumes for an IC engine. The most important one is swept volume. So you might have seen for every vehicle we are associating some number. For example, you have seen Maruti 800. So what is this 800 represents? Is there any significance? Similarly, if you go a Pulsar 250, you have seen Pulsar 250, Pulsar 150. Whether this number is having any importance to the power and mileage of the vehicle? Yes, this is very much influential. And that number is this swept volume in centimeter cube. So that is the importance of swept volume. So normally it will be represented in centimeter cube. or in some vehicle it will be in liter. For example, you can see the Innova. For larger vehicle like Innova, it will be in Innova 2.3. That means 2.3 liter is its sept volume. So what is the importance of sept volume, or what is sept volume? Sept volume is the volume covered by the piston traveling from one dead center to other. So already we can see the distance covered by the piston is stroke. But what is the volume? What is the volume contained in between these two dead centers? That is known as the sept volume. So automatically it will be the area into stroke length. So the length covered by the piston, or the distance covered by the piston from moving one dead center to other, is stroke, capital L. And the area is, we know bore diameter is given. So area will be pi by 4 d square. So pi by 4 d square into L will give the sept volume. So please note down that it is not total volume. It is the sept volume. Sept volume is different than the total volume of the cylinder. So sept volume is volume covered by the piston moving from one dead center to other. And what happens to power of an engine is, normally as the sept volume increase, we can incorporate more air fuel mixture, we can burn more fuel, so power will increase, but its mileage will be reduced. So you can see the power of Pulsar 250 is more than that of Pulsar 150, but mileage will be obviously more for Pulsar 150. So that is the relation general with respect to sept volume. And we have one more volume, that is the clearance volume. You can see a small volume marked here, that is clearance volume. Here you can see what is that. That is a volume left above the piston when it is at the TDC. So you can see why it is provided, because the valves will be continuously moving and upward and downward. So you cannot reach the piston here at the maximum point of the cylinder, because it will hit the valve, it will damage the valve. So you have to provide a small clearance volume here. So clearance volume is the volume left above the piston when it is at TDC here, top dead center. So this volume is clearance volume. So obviously the total volume, what will be the total working volume of cylinder? It will be the sum of sept volume and the clearance volume. So that is sept volume, clearance volume and the total volume. And finally we have an important factor, that is compression ratio. Every engine will have a compression ratio. For example, most of the petrol engine compression ratio will be between 6:1 to say 12:1. But diesel engine will be using a very high compression ratio, that is some 15:1 to 22:1. So that's an important factor which determines the efficiency, power, etc. So what is that compression ratio? So compression ratio is defined as volume before compression to volume after compression. So that we will understand better after studying the working strokes of an IC engine, but still it is the ratio of volume before compression to volume after compression. And volume before compression, that is the beginning of compression stroke, piston will be here at the bottom, BDC. So what will be the volume before compression? So piston is here, so this much volume is available. This total volume will be available before compression. So that is Vs plus Vc. Vs represents sept volume, Vc represents clearance volume. We have already defined this, and total volume is Vs plus Vc. So that much volume will be available to the gas before compression. But at the end of compression, the piston will reach here, TDC. Then what will be the volume available? Volume after compression, only this volume, clearance volume. So denominator will have Vc only. So compression ratio is volume before compression to volume after compression, and therefore it will be Vs plus Vc by Vc, or we can write it as 1 plus Vs by Vc. So that is the compression ratio. So all these are important parameters which we use in solving problems or specificating a actual engine, etc. So first you have to understand what is TDC and VDC, then what is stroke, then what is bore, then what are the volumes related to an engine, swept volume, clearance volume and total volume, and finally what is compression ratio. So next session we will discuss the working of 4-stroke and 2-stroke engine. So thank you.